Thank you for coming to Space Story. Please click subscribe, like, and notification. From 10.6 billion to 10.5 billion years ago, the early universe was an important period of gradual maturation. Approximately 3.2 billion years after the Big Bang, the universe had already expanded to a considerable size, and early galaxies were actively forming. The main characteristics of the universe during this period were as follows. Formation of early galaxies. Due to the influence of gravity, small density fluctuations gradually grew, leading to the birth of the first galaxies. These early galaxies often had small and irregular shapes, unlike the large spiral galaxies with arms we see today. Active star formation. Within early galaxies, gas and dust condensed through gravitational contraction, leading to the active birth of new stars. In particular, many massive and hot stars were created, ending their short lives in supernova explosions and releasing heavy elements into space. These elements became the raw materials for the next generation of stars and planets. Intergalactic interactions. The density of galaxies in the early universe was higher than it is now. So gravitational interactions or collisions between galaxies are estimated to have occurred relatively frequently. These interactions had a significant impact on the shape and evolution of galaxies. Cooling of the cosmic microwave background radiation. The cosmic microwave background radiation, a remnant of the Big Bang, had its wavelength lengthened and its temperature lowered over time. Between 10.6 billion and 10.5 billion years ago, the cosmic microwave background radiation continued to cool, but it still had much higher energy than it does today. The role of dark matter. Dark matter played a crucial role in galaxy formation and structure formation during this period as well. The gravitational pull of dark matter is believed to have acted as seeds for ordinary matter to gather and form galaxies. In summary, the 100 million years from 10.6 billion to 10.5 billion years ago was a dynamic period. In the early universe, when stars and galaxies began to form and evolve in earnest. The early structures created during this period became the origin of the vast cosmic web we observe today. The period from 10.5 billion to 10.4 billion years ago marked an important turning point when the early universe began to have more complex and diverse structures. During this 100 million year period, corresponding to about 3.3 billion to 3.4 billion years after the Big Bang, the galaxies that began to form in the previous era grew and interacted further, and the overall appearance of the universe gradually evolved into a form similar to the present. The main characteristics of the universe during this period were as follows. Growth and merging of galaxies. Early galaxies increased in size through continuous star formation and were also drawn together or merged through gravitational interactions. These galaxy mergers were an important mechanism for the birth of larger and more massive galaxies and contributed to changing the shape of galaxies from irregular to elliptical or spiral. Changes in star formation rate. While active star formation continued in some galaxies, the rate of star formation gradually began to decrease in others. This is believed to have been influenced by various factors such as the depletion of gas within galaxies and changes in gas distribution due to galaxy mergers. Activity of quasars. In the centers of some giant galaxies, quasar activity, where supermassive black holes actively absorbed surrounding matter and emitted very bright energy, became prominent. Quasars were among the brightest objects in the early universe and are believed to have played an important role in the evolution of early galaxies. Formation of large-scale cosmic structures, as galaxies gradually formed groups through gravitational interactions. And these galaxy groups gathered to form larger-scale filaments or walls. The outline of the large-scale structure of the universe began to emerge. The distribution of dark matter played a key role in the formation of these large-scale structures. Increase in heavy element abundance. Due to active supernova explosions in the previous era, the abundance of heavy elements in space gradually increased. This influenced the composition of stars and planets formed later, laying the groundwork for the emergence of celestial bodies with more diverse chemical compositions. In summary, the period from 10.5 billion to 10.4 billion years ago was an important time when early galaxies matured further. Interactions between galaxies became active, and the formation of large-scale structures in the early universe began. With the emergence of celestial objects showing active phenomena such as quasars, the universe took on a more dynamic appearance. The period from 10.4 billion to 10.3 billion years ago was an important stage in the early universe when the initial cosmic structures became more distinct, and the evolutionary paths of galaxies began to diversify. During this 100 million year period, corresponding to about 3.4 billion to 3.5 billion years after the Big Bang, galaxies acquired more complex shapes and properties through active interactions and internal activities. The main characteristics of the universe during this period were as follows. Accelerated formation of galaxy groups and clusters, under the influence of gravity. The rate at which galaxies gradually gathered to form larger structures such as galaxy groups or galaxy clusters accelerated. These galaxy groups became the basic building blocks of the large-scale structure of the universe. Differentiation of spiral and elliptical galaxies. Through galaxy mergers and internal dynamical evolution, early irregular galaxies gradually began to clearly differentiate into spiral galaxies with rotating disk structures and elliptical galaxies where the random motion of stars is dominant. Galaxy mergers are believed to have mainly contributed to the formation of elliptical galaxies. Black hole growth and active galactic nuclei. Supermassive black holes located at the centers of many galaxies continued to grow by absorbing surrounding matter. In some galaxies, the phenomenon of active galactic nuclei, AGN, where hot gas around black holes emitted powerful jets or radiation energy, became more active. Quasars are one of the brightest forms of these AGN, deepening regional differences in star formation. Even within galaxies, star formation activity did not occur uniformly but mainly proceeded actively in dense gas cloud regions. Starburst phenomena occurred in some galaxies, which had a significant impact on the evolution of the galaxies. The outline of the large-scale structure of the universe becomes more distinct. As galaxy clusters and galaxy groups connected to form even larger structures such as filaments or walls, the universe began to take on a form like a giant cosmic web. The spaces between these structures were filled with relatively low-density cosmic voids. In summary, the period from 10.4 billion to 10.3 billion years ago was an important time when early galaxies became more organized and diversified, and the basic framework of the current cosmic structure began to form. Active interactions between galaxies, the growth of central black holes, and regional differences in star formation activity were the key drivers of cosmic evolution during this period. The 100 million years from 10.3 billion to 10.2 billion years ago was an important period when the early universe became more connected in a complex network, and the individuality and characteristics of galaxies began to become distinct. During this period, corresponding to about 3.5 billion to 3.6 billion years after the Big Bang, the universe underwent significant changes in two aspects: the formation of large-scale structures and the internal evolution of galaxies. The main characteristics of the universe during this period were as follows. Development of the cosmic web, as the large-scale structures such as galaxy filaments and walls that began to sprout in the previous era became more distinct and interconnected. The outline of the cosmic web, resembling a giant spider web, began to appear clearly. Galaxies became distributed along the nodes or filaments of this web, and the vast spaces between them expanded further as cosmic voids. The gravitational influence of dark matter drove this large-scale structure formation. Increased diversity of galaxy morphology. The disk structure of spiral galaxies became more stable, and the shapes of their spiral arms also became clearer. Elliptical galaxies became larger through galaxy mergers in the previous era, and the motion of stars within them also took on more random characteristics. Irregular galaxies continued to maintain active star formation and retained their unique shapes. Active formation of galaxy clusters. More galaxy clusters, where galaxies are strongly bound gravitationally, formed, and their sizes also increased. Within galaxy clusters, interactions between galaxies and gravitational influences became more active, significantly affecting the evolution of galaxies. The intracluster space filled with hot gas was also confirmed through X-ray observations. The Golden Age of Quasars. This was the period when the density of quasars, which were active in the early universe, reached its peak. Quasars, which emit enormous energy as matter is rapidly drawn into the supermassive black holes at the centers of giant galaxies, acted like beacons illuminating the early universe. The powerful radiation energy emitted from quasars also affected the evolution of galaxies by heating the surrounding gas and suppressing star formation. Regional differences in heavy element abundance. As heavy elements produced through the evolution of stars and supernova explosions in the previous era spread into space, Regional differences in the abundance of heavy elements began to appear within galaxies or in the space between galaxies. This became an important factor influencing the characteristics of stars and planetary systems formed later. In summary, the period from 10.3 billion to 10.2 billion years ago was a time when the cosmic web structure became more distinct, the shapes and activities of galaxies diversified, and quasar activity peaked. This period became an important stepping stone for the early universe to acquire the complex and hierarchical structure we see today. Thank you for watching the Space Story video. Please click the subscribe, like notification.